So after reading the paper and understanding everything theoretically, I have seen some coding implementations as well. So there was not any official code or open source code we can say like it's started with this paper, but there were some community code or community contributions were available with this. Some like we can say like some 8 code implementations are here and some 14s are here, and I have checked them nearly all. Like for example, from all these, and I found this one which is PyTorch GDN, the we can say like the most accurate, or which I found it we can say which I understand like this is the implementation for this paper, which is like end-to-end uh, optimized image compression. So this repo is called basically PyTorch re-implementation for end-to-end optimized image compression. So that's basically we can say neural network implementation using PyTorch. So I have cloned this repo, and I will show it what I have learned and what I have seen in this code. So basically, this is this repo icelr17 compression. Its name. So we have some file. For example, first of all, let's see this train file. So train.file, just like we can say like which contains the which basically initiate the training. We can say. So it's initiate the training, and we can say like it parts the some configurations and like how much epochs and whatever, and like set up the training loop as well here. So this is the main like training code to just importing the libraries and just setting up the epochs, like test epochs and GPUs and everything, and then setting up some configurations and then adjusting learning rates. So basically whole like we can say which just like run all the code and the basically the training portion of this repo, and there is a main function as well which is handle these things. And then we can say there is one another file which is model.py, and it basically we can say like define the architecture of the compression model, like we can say like including this analysis model here and synthesis model and bit estimator. So basically these are defined in here in models, but we will see. So this is like the model.py. It's just like we can say like explain the overall architecture, like how the overall architecture is, and it's just like in this forward function, it just like applies it. And here this load model function is just like open the file, like open the file and apply the model basically. And then the next one file we can say is the important file, which is dataset file, which is like basically handle the dataset loading and basically pre-processing, and how the we can say I think how the configuration is, how the like training and testing validation should be like done. That is like defined in this file basically. So here just like initializing the thing, and then some defining a getter to like get an image basically in a RGB format, and defining some other configuration thing like how the get loader, train loader will be here, and test codec dataset, and basically build dataset, and here a small main function to build the dataset to just run this class basically we can say. And there is another this file which is like sssim.py, which is basically defining the multi-scale structural similarity, as we have already talked about that in the presentation as well. So there's basically we can say like it is to evaluate the image quality. So it is like for the testing purpose, so it is defining that here we can say, and all the helping function here. And the next one we can say is metric.py. So metric.py defines some other evaluations to just like evaluate it. For example, if we go to, and it defines PSNR and SSIM, and all the helping functions are here. I have seen this code in very detail, but if I go in very detail, it would be like too much lengthy. But I have read the code. I'm not saying like I have down like each line, but I have skimmed the code and I understand like what is happening like in the overall. So how they are doing it basically. And there is some here is meter file as well, which is just like controlling, we can say, which is just like controlling and like for tracking, and we can say logging like how the training metrics should like work. So it is like that thing. So like average meter, weighted meter. So it's just like controlling that thing. And there is some example directory as well, which basically contains the example of, we can say, like configuration file. Like here, for example, epoch should be like this much, step should be this one, training lambda should be this one, LR learning rate should be this one, and date size should be this one. So something like this. And there's basically some shell files as well. And here is some models as well, like we were having, like which we were using in the our architecture. Like for example, there's encoder which is called analysis net or analysis 17.py. That is our encoder, and that is, and then it is like another file analysis prior net, uh, again deep learn our deep learning architecture, another one, and that is again analysis. So these are different variants of the same model which they have built. So one is analysis prior, analysis 17. So in my opinion, analysis 17 is, I think, the latest one. And another dgdn.py, bitestimator.py, and this synthesis, or we can say decoder and decoder prior and decoder.py, we can say basically. So these are some neural network architecture for that. So that's the whole repo is about. Like here, all the models, or we can say like neural networks are defined. Here, the whole architecture thing is defined in the model.py, like how they should be called, how they should be used. Here in the train.py, basically it is running the training loop and starts the training, and this data set is just like build a data set for us, and there's meter.py controls. It serves as a helper class, we can say, and there's uh, metric, and there's the other one, there's one file mssim, so that is like evaluated the whatever we have implemented, just like evaluate at the end. So that's the whole repo. You can also let me know like if I should go like more deeper next time, or I should keep it simple. So that would be very useful for me. Otherwise, I have seen the code and read few things at my end. I understand this code. I mostly work with Jupyter Notebook, like for this, for writing this type of code for this type of training course. But I understand like mostly the code, so I have skimmed through all of it. So thank you very much for listening to this presentation. So hopefully I will join the next week presentation, uh, like in the Zoom meeting, hopefully. So thank you very much.